Today, we're going to cover another method. It's called elimination. So again, you're going to be given a system of linear equations. So two linear equations, and we're going to eliminate one of the variables. And we're going to learn the method today of how to eliminate either x or y. So now remember that an equation is going to stay balanced as long as you do the same thing to both sides. So as long as you add the same number to both sides or subtract, it still stays balanced. So for example, we can multiply our equations by the same number. As long as we multiply all three parts, it's not really changing the equation. So these are the steps, and as we do some examples, you'll understand them. Now, what I recommend you do is line up your equations. So put the x's on top of each other, the y's, and then the numbers. And then we're going to try to eliminate one of the variables. So notice my system here. Notice how my x's are lined up on top of each other, and then the y's, and then the numbers. This is standard form, if you remember this method or this form of the linear equation. Now, our goal in this lesson is to try to make either the x's or the y's eliminate. And in order to do that, they need to have the same number in front, but one needs to be positive and one has to be negative. So notice in my system here, I have a 3x and a 1x, a negative 4y, a positive 4y, and then a positive 10 and a negative 2. Notice when I look at my system, the y's have the same number, but one's negative, one's positive. That's our goal, is to get it in this form. Sometimes we're going to have to multiply the equation by a number to make it the same. But at the beginning, they're already going to be the same numbers, and it's going to be super easy. So notice, once you have one positive, one negative, I'm going to pretend like I'm adding straight down. I'm going to add my x's, I'm going to add my y's, and I'm going to add my numbers. So notice 3x plus 1x is 4x. Negative 4 plus positive 4y gives me 0. That cancels. And then I do 10 plus negative 2, and I get 8. And then now that the y's are gone, I'm left with an equation to solve. I get x, and then plug it back in. So watch. Okay. So you took your system. Notice the system had the y's that were same number, opposite sign. When I go to add these two equations, the y's have canceled out. Okay, so if you look at the steps, first step is to line everything up. So my recommendation, put it in standard form. Try to make either the x's or y's to have opposite signs. And in this case, it was already set for me. So now I add my equations. And then I end up with 4x equals 8, divide by 4, and I get x equals 2. Just like with substitution, as soon as you find the value of one of the letters, plug it back into the beginning. It doesn't matter which. So now on this slide, they took the second equation and they plugged it in. So they put a 2 here for x, and then they solved. They got the value of y and wrote it as an ordered pair. Here's another example. First thing I'm going to do is look to see, are my equations lined up? Are they both in standard form?
No.
Okay.
Wait, yeah.
They're lined up. They're not necessarily with the x and the y, but the y's are on top of each other, and so are the x's, and so are the numbers. Now that I have my equations all aligned with the x's together and the y's, now what I'm going to do is I'm going to add the two equations. So I'm going to add the two y's so these two, and I get 3y. Notice the x's. One is positive 3, one's negative 3. Notice they cancel out. I don't need to see you write this plus 0. You could just jump right to this step, that 3y equals 12. Then you're going to divide both sides by 3, and you get y equals 4. To find the value of x, go back to the beginning and plug it in. Again, it doesn't matter which one you plug it into. The first one, and they're actually choosing, they took what y equals, which was 4, and then they begin their process of solving. You like this method better? Okay, now, it's not always going to be nice and pretty like that with one positive, one negative. Sometimes you're going to have to work for it. But let's look at our next example. So here we go. Here's a little twist to it. Sometimes you're going to have the same term. They're recommending you subtract it. I'm going to show you what I like to do better is multiply one of the equations by -1. So notice in this example, everything's lined up. Notice how I have my x's here, my y's, and then my numbers. Notice my x's have the same number, but one of them's not negative. I need to make one of these 2's negative. And in order to do that, I'm going to multiply one of my equations by -1. They're choosing to do the bottom one. So notice, instead of trying to subtract it, because then you forget.
But wait, don't you need only the x or the y?
Yes.
So since it's a -5 and a positive.
But we need to have the same number. Okay? So they're telling you to subtract. What I don't like about subtracting it is you forget. You remember to subtract the one you're trying to eliminate, but then you forget about these. So instead, what I like to do is take one of the equations, multiply it by -1, and that's what they're really showing right here. They're going to distribute this -1 to all 3 numbers. So I'm going to rewrite the first equation, 2x plus y equals -5, sorry. Now I'm going to distribute the -1 to each one of these. So I'm going to make it a -2x. I'm flipping all the signs. Positive 5y, and then -13. Yes?
Does it always have to be -1?
If you want to just make the sign go opposite, yes. Now, we're going to see later on that it's going to be different numbers and we're going to multiply by a different number. But right now it's just -1. Okay? So basically, if you're given a system and they're already the same number, just change all of the signs of one of the equations. And the math behind it is multiplying it by -1. Now that I have over here a +2 and a -2, now I can add my 2 equations.
So you only multiply by -1 on the second equation?
Yes, you could have chosen. You could have done the first one if you wanted, but just pick one. Either do the first one or the second one. So now the x's eliminate. I get 1y plus 5y gives me 6y, and -5 plus -13 is -18. Divide by 6, and I get y equals -3. Now that I have the value of one of my letters, plug it back into the beginning. Pick one of the equations, it doesn't matter which. I'll do the first one. So 2x plus y equals -5. 2x, and then I'm putting -3 here for the y, and now I solve. Add 3. 2x equals -2. Divide by 2. X equals -1. So the answer here is -1, -1, comma, -3. And the next slide, where they plugged it in. Now, always remember, you can check your answer. So what I could have done is taken the -1, -3, remember this is x, this is y, plug it back into the originals. If it doesn't work, you know you've made a mistake. Here's another example. Notice it's already aligned. The x's are together, the y's, the numbers. But notice my y's, I don't have opposite signs here. I need to make one of these threes negative. And then I can either choose to multiply this whole one by -1 or this one. They decided to do the bottom one. So what again we're going to do, take our original equation, 3x plus 3y equals 15. I'm going to now take this equation here and I'm going to flip all the signs and write it underneath. So now it's going to become a positive 2x, a negative 3y, and a positive 5. Because I've multiplied this all by -1 now. Now I can add the two equations. 3x plus 2x gives me 5x. The y's cancel out. And then 15 plus 5 is 20. Divide by 5. X equals 4. Take that x equals 4, plug it back in to get y. Doesn't matter which. I'll take the first one, 3x plus 3y equals 15. 3 times 4 plus 3y equals 15. 12 plus 3y equals 15. Minus 12. 3y equals 3. Divide by 3. Y equals 1. Order pair 4, 1. And that's what they did on the slide. Good so far? Okay, so it's easy when it's already set. On the quiz, I'm going to give you one question where they're already set for you. One will be positive, one will be negative. You just add them up and cancel. There's going to be another question where you're going to have to times it by -1 to make them opposite signs. And then the last type of question from this lesson is where you're going to have to multiply both equations by different numbers. And we're going to see an example of that. And here we go.
Here is that no substitution on the quiz.
No, there is. Okay, on the quiz, you're going to have 1 graphing question, 3 substitution, 3 elimination, 2 where you just plug in the order pair and tell me yes or no, and then 1 word problem. Okay, so on this one, do I have either my x's or my y's with the same numbers? No, right? I got a 1x here, a -3 here, a 2 here, and a 1 here. I need to make my equations to have either the x's with the same number opposite sign or the y's. You can choose which one you want to solve for. They've decided they want to eliminate the y's. Okay? Now, at the beginning I said, as long as you stay consistent and multiply all 3 numbers by the same thing, it's not really changing the equation. So, what they've decided to do is they want to eliminate y. They want to make this y turn into a -2. How can I make this y turn into a -2? What can I multiply it by?
2.
-2. So what I'm going to do is I'm going to take that second equation, the -3x, I'll write it over here, -3x plus y equals -5. I'm going to times or multiply the entire equation by -2. So -2 times -3 gives me 6x. -2 times positive 1y gives me -2y. -2 times -5 gives me 10. I'm now going to take that equation and I'm going to add it to this one. So now I get x plus 2y equals 11. I'm rewriting the first one. I'm rewriting the one that I just rearranged by multiplying. Now notice, look at my y's. What's going to happen to them? They're going to cancel out. So then now I'm going to add 1x plus 6x and get 7x. 11 plus 10 is 21. Divide by 7, x equals 3. How do I get y?
You plug it in.
Plug it back into the beginning. And again, it doesn't matter which. I'll go ahead and take the first equation. The x plus 2y equals 11. I'm going to put x here. And then solve. 2y equals 8. Divide by 2. And y equals 4. Order pair here is going to be 3, 4. That's what's on the next slide. Is this method better? Now, sometimes you may have to multiply both equations. So sort of think like common denominators. So look at this one.
Fraction.
No, not fractions, but just think, okay, what can I do to make, what can I multiply this equation and this equation by to make these have the same number? I can multiply this one by 2 and this one by 5 to make it turn into a 10. What can I make these two? What can I multiply 2 and 3 to make them 6s? Does that make sense? So sometimes you'll have to multiply both equations by a number to make them eliminate. So, all right, they did it by making the x's 10s. So they multiplied this whole equation by a 2 to make this a negative 10x. They multiplied this one by 5 to make it 10x.
Just like those going on.
Exactly. Now, let me show you by eliminating y. Okay? So, and you'll have a question like this on the quiz. All right, I want to try, they did x first. I'm going to try to eliminate y first. What number am I going to try to make y? So it's the same? What's the common denominator between 2 and 3? 6. So what do I have to times 2 by to make it 6? 3. So I'm going to multiply my first equation by 3. This will become a negative 15x plus 6y equals 96. Now, I want this to become a 6, but a negative 6. What can I times 3y by to make it a negative 6?
2 is already negative.
So negative 2, right? So I'm going to take my second equation, 2x plus 3y equals 10. Multiply everything by negative 2. Get negative 4x minus 6y. I'm sorry?
Why is it negative?
Because when I go to add these, so now when I put this one with this one, I need a positive 6 and a negative 6. Now, I could have done a negative 3 here and a positive 2 here. It doesn't matter. You can choose. Okay, so now that I have my two equations here, I'm going to put them on top of each other, line everything up, and then begin to solve it. So negative 4x minus 6y equals negative 20. And then on the bottom, the 15x plus 6y equals 96. This cancels. This gives me negative 19, and this gives me 76. Divide by negative 19, and I get x equals, let's see, 4, negative. And then plug it back in to get the y. They solved for y first. You can choose. It doesn't matter. It's not just a set method. Yes?
Do you have to plug it back into the one that you multiplied?
No. You can go back to the original. You could do it to the multiply. You still get the same answer.
And
It just,
does it matter which one you multiply?
no. All right. And then here it is, negative 4, 6. Here's another one. Again, it's lined up. I always look for the smaller the number to do it. They ended up doing this one by 3 because it already had a negative. You could have done this one by negative 2. It doesn't matter. Everybody see that? Your goal is to make either the x's or the y cancel out. They chose to multiply this equation here by 3. Then it turned into this, and then you can see the x is canceled. Making sense? A little bit easier, right, than the other methods? How much time we got? All right. That's pretty much it for the elimination method. We can go ahead and do some of the homework together. There is a word problem. The word problem on the quiz, I don't care which method you use, so you can choose. Let's go ahead and look at the homework. It is